In emergency situations, how can we transform the noise of digital and social media into meaningful information for disaster response and recovery?
CogniCity open source software is infrastructure for climate change adaptation because people are the best sensors in the city. They can share updates in real time through social networks.
And by making the data open, we create new possibilities for civic co-management between residents and first responders.
We give information to all public, to all citizens that living near the river, to prepare for evacuation or prepare the flood will be coming.
Which allows government agencies to share information openly and freely and to make more informed decisions during emergencies.
So we're going to take you behind the interface to show you how open source software and open data are working together to help megacities adapt to climate change.
As cities become increasingly complex systems of people and interconnected infrastructure, extreme weather events and long-term environmental changes pose new challenges for urban governance. Our question is simple. How can we couple the use of open data and open source software to help the residents of megacities adapt to climate change? With support from the Open Data Institute, this video explains how CogniCity open source software gathers and disseminates flood data through the most comprehensive digital sensor network that the world has ever seen: internet-connected mobile phone users. With over 31 million residents, the greater metropolitan area of Jakarta has one of the highest rates of urbanization in the world. The city is home to 13 rivers, 1,100 kilometers of canals, and a complex hydraulic infrastructure. Among the many hazards faced by residents in the city, flooding during the monsoon season is particularly severe. Annually, Jakarta's residents also generate 2.4% of the world's tweets on the social media platform Twitter. With some of the highest concentrations of social and digital media usage in the world, residents actively use their social media networks to gather and share information about disaster events, especially floods. Although rapidly urbanizing megacities like Jakarta are often thought to be data scarce, by enabling residents to share flood data openly and in real time, a wealth of information can be leveraged to promote resilience to extreme weather events. CogniCity is free and open source software developed by the Open Source Geospatial Lab at the Smart Infrastructure Facility at the University of Wollongong. It gathers, sorts and displays crowdsourced data, thereby making accurate information available in real time to residents, community networks and government agencies. Powered by CogniCity software, peterjakarta.org is the first map of its kind to produce a megacity-scale visualization of flooding, using both crowdsourced reporting and government agency validations in real time. The map displays the rapidly changing conditions that affect infrastructure systems and their users, providing immediate information for residents, first responders, and municipal agencies. By enabling reliable, non-trivial communication between users and government agencies, the platform promotes civic co-management as a form of megacity climate change adaptation. In order to aggregate, sort, and display accurate time-critical information from a variety of data sources, CogniCity is organized into 3 software modules. The Reports module is CogniCity's interface with external data collection platforms. It collects information about flooding, river heights, and infrastructure performance from a variety of sources. The Database module stores the collected information for a specified duration of time, in order to ensure the relevance of real-time flood information. The Server module serves this data to a client interface, the peterjakarta.org webpage, viewed either on a desktop computer or on a smartphone, providing users with access to data in real time. By gathering, sorting, and visualizing data, CogniCity transforms the noise of social media into critical information for residents, communities, and government agencies. The free web-based platform peterjakarta.org has been used by hundreds of thousands of residents during monsoon flooding. It is also used by the Jakarta Emergency Management Agency to monitor flood events, to improve response times, and to share emergency information with residents. Harnessing the extensive use of Twitter in Jakarta as an information sharing platform during flood events, CogniCity gathers tweets about flooding and organizes them into two categories: unconfirmed and confirmed reports. Unconfirmed reports are tweets from Jakarta with geolocation metadata that contain a specific word, such as flood or banjir. The reports module listens for these tweets via the Twitter API. When CogniCity detects an unconfirmed tweet about flooding, the reports module programmatically sends a reply tweet to the user, inviting them to confirm the situation. This invitation message contains a video explanation of the project and provides instructions about how to submit a confirmed report. A new user never receives more than one programmatically generated invitation. To respond to the invitation, the user submits her confirmed report to @PeterJKT. Upon receipt of the confirmed report, CogniCity then sends the user a thank you message with a link to the report on the flood map. Upon refreshing peterjakarta.org, the report is then rendered visible on the map. The reports database stores reports for 2 hours to ensure that the map only displays relevant, up-to-date flood information. The second category of tweets, confirmed reports, are those sent directly to @PeterJKT with geolocation metadata and the word banjir or flood, in addition to other flood-related information. Upon receipt of these confirmed reports, CogniCity again generates a thank you message with a link to their report on the flood map. Upon refreshing peterjakarta.org, the report is visible on the map. Third, if a confirmed report is sent to @PeterJKT without geolocation metadata, CogniCity programmatically sends the user a reminder to enable geolocation and encourages her to resubmit the report. The platform adopts a people as sensors paradigm, where confirmed reports are collected directly from the users at street level in a manner that removes expensive and time-consuming data processing. This framework creates accurate real-time data, which is immediately made available for users and first responders. Designed as a platform to support dynamic communication among residents, their communities, and government agencies, peterjakarta.org enables users to differentiate easily between verified government reports and confirmed resident reports, rendering these two types distinctly on the map. To check for reports verified by the Jakarta Emergency Management Agency, CogniCity compares retweets from the agency and tweets stored in the database module. Any matches between the two are then stored as verified reports on the database module. Upon refreshing peterjakarta.org, these verified reports appear as blue report icons on the map, allowing users to distinguish between the verified government reports and the confirmed resident reports.
Expanding the range of data sources allows people to report emergencies with their preferred platforms and increases resilience. During emergency situations, when information sharing peaks and platforms are working at their maximum capacity, data and platform diversity ensure resilient communication.
In addition to Twitter, peterjakarta.org partners with other local platforms that gather relevant flood data through crowdsourcing. Reports sent to the Smart City Jakarta application, Clue, are shared via an open API. Reports sent to the datik.com citizen journalism platform, Pasang Mata, are manually verified by operators and then shared with CogniCity via an open API. The reports module listens for updated reports from these platforms. When a user refreshes the map at peterjakarta.org, CogniCity supplies the new confirmed reports coming in across all three platforms. The integration of data from multiple platforms enables efficient cross-checking to corroborate flood reports. Integrating and visualizing data from different platforms also helps to assess different infrastructure components and analyze their performance during extreme weather events. The map base layer data on peterjakarta.org is obtained from OpenStreetMap and served via Mapbox. This allows the platform to build on a solid foundation of open data and to work in an open information ecosystem. Locations of water pumps, floodgates, and waterways were manually collected by the field research team. This information is stored in the database module and made freely available through an open API. When a user accesses the map at peterjakarta.org, CogniCity's server module provides access to the infrastructure data in order to display these layers on the map. These infrastructure layers are optional and can be turned off.
Understanding infrastructure performance is critical for disaster management professionals during extreme weather events. By combining data from sensors located within the hydraulic infrastructure networks with crowdsourced data from residents, we have a better understanding of the overall situation in the city, and we can monitor problems that arise in real time.
In addition to displaying crowdsourced reports, the map also aggregates information from other government agencies, such as river gauge data. River gauge data supplied by the Jakarta Emergency Management Agency is recorded into the database module and stored for 12 hours. Upon refreshing the map at peterjakarta.org, updated river gauge information is rendered on the map through color-coded icons, based on the measured water levels. Upon clicking a river gauge icon, a pop-up graph expresses the change in the river's water level every hour. This layer is optional and can be turned off. Government agencies are already measuring infrastructure performance. By synthesizing available data from these agencies and sorting both formal and informal sources of data, the platform makes publicly accessible a robust, concise collection of real-time flood information. The CogniCity Risk Evaluation Matrix facilitates greater information sharing and data coordination among residents and government agencies. The risk matrix has its own reports, database, and server modules in order to manage sensitive information and maximize performance. The risk matrix allows emergency operators to input flood height data derived from various sources, including flood reports from peterjakarta.org users, government field officers, and NGOs. Flood heights are displayed at a neighborhood scale as polygons rendered in varying shades to represent the severity of flooding. When it is input by the operator, this data is also recorded into the risk matrix database module. Upon refreshing peterjakarta.org, updated flood height information becomes publicly accessible to resident users. Flood heights are an optional layer on the map and can be turned off. Flood height data is stored in the database module until an operator manually turns it off. The risk matrix helps the emergency services alert residents to the locations of flooded areas, but also to integrate reports from users into a dynamic information sharing process as part of civic co-management. In order to integrate rapid assessment reporting into a single enterprise-level platform, the risk matrix is designed to work with GeoData Collect, a mobile application developed by the humanitarian OpenStreetMap team in Indonesia for disaster-related field data collection. Users can download forms and submit responses regarding internally displaced people, shelters, and other humanitarian needs, tagged with the geolocation metadata. These reports are stored on the humanitarian OpenStreetMap server. The risk matrix connects to this server via an API in order to display reports on the secure risk matrix map. Risk matrix operators can view these reports and make decisions based on this vital yet sensitive information. Critically, the reports are displayed alongside all other flood-related data from peterjakarta.org, making assessment and analysis more accurate and effective.
The power of interoperability is that it allows the best of breed of software to work with each other, providing benefit to all of their users.
As organizations work to reduce disaster risk, the ability to draw upon and contribute to a rich and open information ecosystem accelerates climate adaptation in our dense network megacities.
As new tools, applications, and software are adopted by municipal governments and NGOs for the identification and management of urban risk as a result of climate change, the need for greater integration of various data they collect becomes acute. An output API stream gives secondary applications open access to CogniCity's data, enabling them to optimize their performance with an array of open data. During and after disaster events, evidence shows that residents self-organize using digital infrastructures. In order to handle the peak of data traffic during these emergency situations, when access to accurate time-critical information is most important, the web server running CogniCity is programmed to scale virtually to meet peak demand. In this configuration, CogniCity is able to handle high volumes of traffic during disaster situations, without requiring expensive but idle servers during off-peak times. Running a dynamic set of virtual servers on top of a well-maintained hardware platform allows CogniCity to provide resilient, flexible services that respond to extreme weather events. Designed within Amazon Web Services, CogniCity leverages the scale and capacity of cloud services, thereby minimizing CogniCity's impact on the climate change events that the system helps to monitor.
One of the things we want to emphasize is that CogniCity open source software can work as infrastructure for climate change adaptation precisely because it is not a standalone application. Instead, By connecting to social media, hydraulic sensors, and other urban applications, CogniCity creates an open, medium-agnostic platform that redirects existing systems to support disaster response and humanitarian action.
CogniCity has proven the value of crowdsourced social and digital media for emergency response through the peterjakarta.org platform. But this use of open data for climate change adaptation is only a small first step. Additional CogniCity modules are now being developed to address other hazards, including earthquakes, volcanoes, tsunamis, typhoons, and terrorism. CogniCity is also being designed to integrate and coordinate additional data sources, including various instant messaging services. And as CogniCity is deployed in other megacities in South and Southeast Asia to meet the challenge of climate change adaptation, the combination of open data and open source software will be critical for coordinating humanitarian action. As the CogniCity software is further developed to address new risks, data inputs, and urban geographies, co-research with residents, community organizations, government agencies, and allied platforms will continue to advance the science of geosocial intelligence through open data.